So today we're going to talk about production possibilities in the whole economy and the implications for economic growth. You remember the last time we talked about the idea that in economics you make choice, purposeful choice, but there's a scarcity of options. You also interact with people. You can think about this for individuals, deciding whether you take economics or biology, or whether you go to college or don't go to college. Those all incur opportunity costs. You can also think about it for the economy as a whole. If you produce more health care, you're going to produce something less of something else, and that's what the production possibilities curve is all about. So we're going to talk about that today, and we're going to use a numerical example of these production possibilities. The numerical example is just made up. We're going to think about the options between producing movies and producing computers. We could do guns and butter, we could do healthcare and other kinds of goods. Just an example of this idea of production possibilities in the economy. So you want to imagine the economy at pretty close to normal times, full employment if you like, resources are available to use in different sectors, and then decide and think about what happens as sectors get more or fewer resources from time to time. And this numerical illustration tries to show that. So there's several options. You can produce no movies, in which case you get 25,000 computers. Just all the resources in the economy are going into producing computers. Or you can make a few more movies, say 100 for example, and in that case you get fewer computers. That's the opportunity cost. Remember, the opportunity cost of producing more movies is less of something else, in this case, fewer computers, 1,000 fewer computers. If you produce more movies, say 200 rather than 100, that's an increment of 100 if you think about it. You also get fewer computers, but in this case it's even more of a loss. You get 2,000 reduction from 24,000 to 22,000. So that's another cost, opportunity cost, right? But it's a higher opportunity cost. It's increased from 1,000, go to 25 to 24,000, and now it's 2,000, 24,000 to 22,000. So the increment is bigger, and that's what we mean by increasing opportunity costs. You can go further down the table, say 300 rather than 200, and then you're going to have an additional opportunity cost. In this case, you go from 22,000 to 18,000. And you'll just go right down the line. The last idea is you go to the producing only movies in this economy, no computers. I know that sounds crazy, but if you go from 400 to 500, it's a huge opportunity cost, 13,000 computers that are not being produced. Now, why do you have this increase in opportunity costs? Well, the reason is that resources tend to be specialized. If you move people out of working on the computers into movies and it's at the beginning, just a few workers going out of computers into movies, they may not be that good at computers. They could do movies just as well. Rather than program computers, they could be actors. They're just as good at it. It doesn't really hurt the production of computers that much. But as you get fewer people doing the computer business, you're losing your more skilled, more specialized workers, and that costs in terms of computers. So at the extreme where you're basically taking all of the workers and putting them in the movies, then you have really skilled programmers who are not very good actors, and you're getting a little bit more movies, but you're really subtracting dramatically from the capability of producing computers. And that's what causes this increase in opportunity costs. It's a very important concept. It's different than just opportunity costs. It's increasing, as this table indicates. Now, often in economics, you can get more intuition and more understanding of a subject if you look at some pictures, at some graphs, not just look at the numbers. So I'd like to take those numbers and plot them on a piece of paper, and we'll see what we learn from that. So I'm going to take a graph and draw it up here best I can. Of course, lines are a little squiggly, and I'll put on this axis the movies, and I'll put on this axis the computers. And I'm going to put some scales because we're going to plot numbers. So this would be 100, say 200, 300, 400, 500 movies, 300, 500, say. And then we have to plot the computers as well, and they're going from up to 25,000, so we could say 5,000, 10,000, 15,000, 20,000. Didn't leave much room, but there's 25,000 up there. You get the picture. And now we want to just plot the points from the table. So we know if you're producing no movies from that table, if you remember, you get 25,000 computers. If you're producing 100 movies, then it declines a little bit to about 24. If you're producing 200 movies, then it declines a little more to 22. If you have 300, then it's going down to about, say, 15 right there, and then it continues down. If you're producing 400 movies, it's 13,000, and then finally 0. And so that's just plotting the points. I'm not doing anything except plotting the points on this graph. But now what happens when you connect the points? You see something that looks like curvature. I'm just connecting those dots, not doing anything else fancy, just connecting the dots. And what you can see now, if you look carefully, is there's some curvature in this picture. And that curvature is due to the increasing opportunity cost. The line gets steeper as you go off to the right. And that's the increasing cost, the increasing reduction in each increment of computers that you get from making more movies. So you'll see the computers are on the vertical axis and the movies are on the horizontal axis, and the points are there plotted with A, B, C, et cetera, and you can now see the curvature of this production possibilities. Now once you draw it, you have a new name. It's called production possibilities curve. And the production possibilities curve is just a description in graphical form of that numerical table. It's the same thing, nothing new, just the same kind of thing in graphical form. But when you get this graphical form, again, that curvature is important. By the way, if it was just not increasing opportunity cost, but constant opportunity cost, then it would be a straight line. That wouldn't get that curvature. But we think curvature is a more natural description of how the economy works as resources move from one sector to another. You also notice this graph now gives you a chance to talk about some other concepts which are really important. First of all, you can't produce, say, for example, 30,000 computers and 200 movies. That's not a possibility. In fact, that's off the graph. That would be up here somewhere, up there somewhere. You can't produce that, or you can't produce over here either. It's over 500 movies and 5,000 computers. Those points are not possible. They're impossible. They're off the production possibilities curve, and so that's not in the cards. You also can be really inefficient, have, for example, people who are not very good at acting. They'd be much better working than the cameras, but you make them to be actors, and you get a very inefficient production of movies. And so that's the inefficient area where you're producing a smaller number of movies and computers than you're capable of producing. It's inefficient. The best point is to be on the line. That's kind of like a frontier. Economists call it the frontier for that reason sometimes. Those are the efficient points. And those efficient points are what the goal should be, is to get to those points, somehow get the economy working in an efficient way. We're going to describe in this course what's the most efficient way to do it. What's the way to do it? Should you use the markets? Do the markets always produce these efficient outcomes? Does consumer choice generate this? That's the real question. But we'd like to be at those efficient points. And that's really what the production possibility curve can tell you. Now, one thing about the idea of scarcity and production possibilities and impossibility, it makes you think, this is kind of a dismal science. I mean, where does progress come from if you're always stuck there at that efficient point? Well, progress comes because over time, that curve can shift out. That curve can shift out because you get better at making computers. The computers themselves can help you make better movies. And after all, for the economy as a whole, there's millions and billions of products that help improve our technology and allow us to produce more for the same amount of effort, the same amount of work. You can illustrate this with the production possibilities curve as well, as having it shift out over time. So the curve so the inside curve there could represent the trade-off, the production possibilities curve, say in 1960, and the one at the top could represent the one in 2025 or 2030 or whatever you're thinking about. You get this progress over time. There's also another interesting thing about the trade-off and how you get progress, and that has to do with what kind of goods you're producing. Now, in this example, we've used kind of the silly idea of just movies and computers. Again, you could have all sorts of things, healthcare or not healthcare, but movies represents a kind of production that's for consumption. People consume, they go to the movies, they enjoy themselves. Whereas computers represents a kind of production for investment, for the future. Those computers can be used down the road to write better, to produce better products, to do more things efficiently. So it's kind of an investment in the future. And that's different from the consumption. And what economists have found is investment gets you to move that production possibility curve out more than consumption. Consumption doesn't really lead to much more growth, whereas investment will. So if you choose a point on this graph, and let's think about the movies as representing consumption, and you pick a point on this graph, which is a lot of movies and not much computers, then that graph's not going to shift out very much. If you, on the other hand, choose a point where you're doing a lot more of computers and relatively few movies, actually that's probably too low, it looks probably depressing, so very few movies, but then you move out a lot more. Over here, you don't move out very much. And that's really emphasizes the importance of investment versus consumption in the economy. So there's a lot you can do with this curve. Now one thing, when we move the curve out this way, it represents growth, represents more production for the same amount of work, quite frankly. And so it's a huge benefit to people. This example is just an example, as I mentioned. It's made up. It shows you this important concept, but it's not the exact numbers in the economy because you've got so many different products besides just these two. But you can describe this progress with data that is quite accurate about the progress, and that is to get a measure of the total amount of goods and services produced in the economy. We call it gross domestic product. Again, it's all, not only movies and computers, but it's concerts, it's education, it's cars, everything that the economy produces, all added up in a way that makes sense. I'll talk about how it makes sense later. And then you see how it grows over time. You also want to make sure that you don't take account of inflation in the wrong way, because everything increases over time with inflation, and so you want to take that out. Economists call that real gross domestic product, sometimes real GDP. And when we take that out, it's a much better representation of what's happening in the economy. Now this chart shows you what's happened in the U.S. economy over a number of years from the late 1940s until the present. If you look at the vertical axis, it's giving you billions of dollars. So it's, you know, from roughly 2,000 billion, that's 2 trillion in the late 1940s, to over 14,000 billion now, 14 trillion. So that's a lot of progress, and that's this shifting out of the curve. By the way, when you look at a curve like this, and you look at the upper, in this particular case, look at the upper right, you see a dip. So that dip was the big recession in the United States in 2007, 8, and 9. We're coming out of it a bit. We're still kind of below the trend. And that kind of a recession represents kind of unused resources, probably one of the inefficient points in our production possibilities curve. You sort of fell back inside the curve, and you hope to get back to the curve. But in the meantime, that curve is shifting over time. When you think about progress, like this curve is representing, it's important to note that workers are producing more. And there are an increase in the number of workers in the economy in this period. So take a quick look at this while we're looking at production. These are the workers who are producing the goods and services. Here we look at the same span of time from the late 40s until the present. The vertical axis is showing you the number of workers employed in the United States over this span of time. The units are thousands, so that point to the far left at the bottom is about 60 million workers. You know, we come up to roughly 140 million. Again, you see this distressing dip here towards the end. That's really decline in employment, which is dramatic in the U.S. at that time. It's, again, you can see the sense in which resources aren't being used. But what you really want for progress is for workers not only be working, but for them to produce more and more over time, because by producing more, people earn more and their standard of living goes up. And so if you take GDP, which we looked at, and you divide it by the number of workers, which is in this picture, you get the amount of GDP per worker. that increases over time as well. And that represents progress. That represents increased incomes because people are producing more, and it's quite dramatic over time. So the production possibility curve is a concept that represents a frontier. The frontier moves out. It has curvature because of the increase in opportunity costs. We illustrate it with these simple examples, numerical and graphs and stories. Remember, economics you describe with numbers, examples, with graphs, with stories. Sometimes you use mathematics too. We're not doing that right now. Different ways to describe the same thing, but ultimately you want to make sure it relates to the real world. And by looking at a concept like gross domestic product, the total amount of goods and services produced, you can relate these ideas, theoretical ideas, to the data. While we're thinking of data and thinking about comparison, why not look at another country besides the United States? What happens in another country? Well, take China. China, for example, you can do the same thing. You can look at real GDP adjusted for inflation. You can divide it by the number of workers to get GDP per worker. And you see a dramatic increase in the product per worker, the productivity of the workers over the span of time. These numbers are all less than the United States because China is still very much of a developing country compared to the United States. But the progress is dramatic. And a lot of that progress, as you can see in the graph, began in the 1980s. And that's another question is, why did it occur then? What would happen in the early to mid-80s that made that line get going in such a dramatic way? We'll be studying those kinds of things in this course and using the ideas of economics to explain that as well.